Good morning. Good morning, dear student. In the last class, we have discussed what are colligative properties. What are a colligative property? What are colligative properties? The properties of the solution or dilute solution, which depends upon what? Number of solute particles, not on its nature. This we have discussed in last class. There are four colligative properties. What are they? RLVP, relative lowering of vapor pressure. Second one is elevation in boiling point, depression in freezing point. The fourth one is osmotic pressure. Out of that, we have discussed the RLVP, relative lowering of vapor pressure. What is relative lowering of vapor pressure? P01 minus P1 divided by P0. This is a relative lowering of vapor pressure. Yesterday we have discussed completely. The numerator is what? Lowering of vapor pressure. Denominator is what? Vapor pressure of the pure solvent. See the what Raoult's has shown, it is equal to a mole fraction of the solute present in a solution. Finally, we came to this equation. P01 minus P1 divided by P01 is equal to W2 by M2 into M1 divided by W1. This equation we have discussed in the last class. This is used to determine the molar mass of the solute M2. Here M2 is what? A molar mass of the solute. Already I told these colligative properties are used to measure the molar mass of the solute. This is the first colligative property we have discussed. That is the RLVP. Here W1 and W2 are mass of the solvent and mass of the solute. M1 is the molar mass of the solvent. P01 is the vapor pressure of the solvent. P1 is the vapor pressure of the solution. So you can determine the M2. I have given one problem. I think you have all of you solved that problem. So the point already I told, the point of examination, the determination of molar mass is very, very important. You will have one problem in your exam. So all to solve this problem. Only thing is you have to write the equation and substitute the values. You will get the answer. Only thing is you have to remember the equation. Otherwise, you cannot solve the problem. So after that, we have started the elevation in boiling point also. After that, we have started the elevation in boiling point. Elevation in a boiling point. Already yesterday we started. What is the boiling point? The boiling point. Why the boiling point of the solution? Suppose you have a water, a pure water or any solvent. Its boiling point we are called as a PB0. PB0. Yesterday I told what is the temperature boiling point. Not is represent the pure solvent. Suppose you have a solution. Water. Sugar is dissolved in a water. This boiling point is called PB. Boiling point is called PB. So, what is elevation in boiling point? Delta TB. Delta TB is equal to TB minus TB0. This delta TB is called elevation in boiling point. This you have discussed in the last class. What the experiment shows. Already we know that this is a colligative property. Colligative property means what? It should depend upon the number of solute particles. Therefore, what the experiment also shows the same, delta TB is proportional to M What is a small m? It's the molality of the solution. So, or delta TB is equal to a KB into M. The KB is called a proportionality constant is called a molar elevation constant. What is called? Molar elevation constant. We have discussed it unit also. KB is equal to Kelvin kg per mole. The delta TB is equal to now delta TB is equal to KB into M. What is M? The molarity. We have discussed in a first class. W2 by M2 into 1000 divided by W1. What is molarity? Number of moles of solute dissolved in a 1000 gram of the solvent. So, see what are W1 and W2? What are W1 and W2? Already you know, one is stands for a solvent, mass of the solvent, mass of the solute, molar mass of the solute, and Kb is what? Molar elevation constant. Its value is depends upon the nature of the solvent. See, this is the second colligative method, property method. Delta Tb is equal to Kb into W2 by M2 into 1000 divided by W1. So this is the second colligative property method. You can determine the molar mass of the solute. Molar mass of the solute. M2 is a molar mass of solute. Here, what are the things you have to know? W1 and W2. Kb is a constant. It's a constant for a given solvent. So, and you can determine the M2 by knowing the colligative property. What elevation is boiling point? What is the elevation in boiling point? The boiling point difference between the solution and solvent. The boiling point difference between the solution to the solvent is called elevation in boiling point. So here also the problem is important. You should remember the equation. How you remember the equation? Delta TB is equal to KB into M. KB into M. Already you know what is M. You have to remember what is M. So M is W2 by M2 into 1000 divided by W1. So this is the second method. Here also one problem is there in the textbook. The so 1 gram of non-electrolyte, a solid. 1 gram of non-electrolyte solute is dissolved in a 50 gram of benzene. Is dissolved in a 50 gram of benzene. Sorry, this is the. It's not a problem. The boiling point. Sorry, I'll put the problem. That was another problem. The boiling point. The boiling point of benzene is 353.23 calories. It's the vapor boiling point of the pure solvent. And 1.80 gram of non-electrolyte, a solute is dissolved in a 90 gram of benzene. The boiling point is raised to the boiling point is raised to 354.11 calorie. Calculate the molar mass. Calculate the molar mass of a solute. Calculate the molar mass of solid. Kb for the benzene is 2.53 Kelvin kg per mole. So this is the problem. What are these things he has given? The boiling point of the benzene is 353.23 Kelvin. The boiling point of the benzene is 353.23 Kelvin. This is the what the TB naught. TB naught is equal to what? 353.23 Kelvin. Then 1.80 gram of 1.80 gram of non-volatile solution is what? W2 is equal to 1.80 gram. It dissolved in a 90 gram of benzene. Is dissolved in a 90 gram of benzene. W1 is equal to 90 gram. And the boiling point is raised to 354.1. The boiling point of the solution is what? 354.11. And Kb is given 2.53 Kelvin kg per mole. So, see what are the quantities they are given? What are required? W1, W2, delta Tb, Kb. And you have to calculate the M2. All are given. What are given? Tb naught is given. Tb is given. Therefore, delta Tb is equal to what? Therefore, delta Tb is equal to what? Tb minus Tb naught. What is Tb? What is Tb? The boiling point of the solution. 354.11 minus the boiling point of the solvent. Which is the solvent is what? 353.23. 353.23. I think it's a 0.88 Kelvin. Delta Eb is equal to 0.88 Kelvin. Kb is given. W2 is 90. Therefore, what? M2 is equal to what? M2 is equal to Kb into W2 into 1000 divided by delta Tb into W1. So substitute this value, you will get an answer. So all should do this problem. All of you. Say I will the same problem I will post in a WhatsApp also. All should try. Only thing is it's a very easy. Only thing is you have to remember the equation and you should understand what are given in a problem. Which equation you have to use. All these things you have to know. Then only write the formula, substitute the value, and you will get the answer. Okay, this is the second method. This is called elevation in a boiling point method. So you see again the what? The colligative property. Why it's a colligative property? So what the experiment shows? Delta Tb is proportional to a molality of the solution. The molality means what? Again the concentration. Concentration is depends upon the number of particles. Therefore, it's a colligative property. The third method is depression in freezing point. What is freezing point? You know water freezes at water freezes at 0 degrees centigrade. The conversion of liquid into a solid. What is actually the freezing point? How do you define the freezing point? A temperature at which vapor pressure of the liquid is equal to vapor pressure of the solid. The temperature is called the freezing point of the liquid or the freezing point of the solvent. So here the word depression is the freezing point. What is depression? The freezing point of the solution is lower than the freezing point of the solvent. For example, if you have a water, you know its freezing point is 0 degrees centigrade. If it is dissolved with a small amount of sugar or any solute, then its freezing point is less than 0 degrees centigrade. The freezing point of the solution is less than the freezing point of the water. This difference is what is actually difference in freezing point? Suppose Tf naught, Tf naught. T means temperature, F is stands for the freezing point, naught means the pure solvent. Its freezing point, Tf naught is the freezing point of a solvent. Here is the freezing point of a solution. The difference is delta is the difference temperature in the freezing point. Delta Tf is equal to what? Tf naught minus Tf. There Tb minus Tb naught. Why? Here is a delta Tb, or you can write it like this, Tb minus Tb naught. Here Tb is more than Tb naught. Here Tf naught is more than Tf. Therefore, you are writing Tf naught. It is a, what is a differential in freezing point? It is the difference between them. It is the difference between the freezing point of the pure solvent to the what? The freezing point of the solution is called the depression in the freezing point. Again, the experiment. Here also, yesterday we have drawn the graph. There we show that how the freezing point of the solution is. The boiling point of the solution is more than the boiling point of the solvent. Here also, this suppose you have this is a vapor pressure. Y-axis is vapor pressure. X-axis is temperature. Go on decreasing the temperature, it is a solvent. Go on decreasing the solvent, its freezing vapor pressure is decreases. One temperature, at one temperature, the vapor pressure of the liquid is equal to the vapor pressure of the solid. This is called a freezing point. This is called Tf naught. See, further decrease, it's a frozen solvent. It's a frozen solvent. So for the solution, suppose you draw the graph for the solution graph is like this is a solvent. This is a solution. The freezing point of the solution also, the vapor pressure of the solution also decreases, and it reaches to the vapor pressure of the solid. So this temperature is called Tf. This temperature is called Tf. This difference is called Tf. Delta Tf. Delta Tf is what? Depression in a freezing point. This difference, what is the difference? A freezing point of the pure solvent minus freezing point of the solution. This difference is called delta Tf. This is called a depression in a freezing point. What the experiment shows, here shows here also that the depression in freezing point, delta Tf is proportional to m. Here also what the experiment shows, the delta Tf is proportional to m. What is the m? M is molality of the solution. Already we have discussed. So here delta Tf is equal to Kf into m. There we have written Kb into m. Here we have Kf into m. There we have written delta Tb is proportional to m. Delta Tb is equal to Kb into m. Here Kf into m. What is Kb? Molar elevation constant. Then what is Kf? Molar depression constant. So this constant value of the constant is depends upon the nature of the solvent. For given solvent, its value is constant. Already we know the Kb for water is what? 0.52 Kelvin kg per mole. Similarly, Kf for water is 1.86 Kelvin kg per mole. The different solvent has different Kf value. Anyway, they will provide for you for the problem. So, what is molality? Already we have discussed what is molality. Molality is equal to what? Kf into W2 by M2 into 1000 divided by W1. Delta TF is equal to what? Kf into W2 by M2 into 1000 divided by W1. You know what is delta TF? It is a depression increasing point. Kf is what? It's a constant. This constant is called molar depression constant. Molar depression constant. W2 by M2. W2 by M2 is use the number of moles of solute and 1000 divided by W1. W1 is W2 are mass of the solvent and mass of the solute respectively. And Kf is a constant. Delta Tf is a what? A colligative property. Which colligative property? Depression in a freezing point. By measuring the delta Tf, you can find out the, or you can calculate the molar mass of the solute. You can calculate the molar mass of the solute. This is the another method. The third method to determine the molar mass of the solute. Here also the same. What are the quantities you are required to calculate the molar mass? One is the delta Tf is required. Another is the Kf, W1 and W2. Only you have to find out the M2. So one more problem is there. One problem is there here also. Uh, the problem is like this. 1 gram of non-electrolyte. Why this word non-electrolyte are we using in problem? We shall discuss that in a later. Non-electrolyte, a solute is dissolved in a 50 gram of benzene. Here again the solvent is benzene. In all three problems we have discussed the same solvent benzene only. 50 gram of benzene. Lower the freezing point of benzene. Lower the freezing point of benzene. Freezing point of benzene by 0.40 calories. The freezing point depression constant. The freezing point depression constant. For benzene is 5.12 calories kg per gram. Find the molar mass of the solvent. Find the molar mass of a solute. Again, what is your question? Find the molar mass. Find the molar mass of the solute. So, what are given? What is the equation? See, once you read the problem, here what is given? A freezing point. The freezing point is given is which method? A differential in freezing point method. See, how do you remember the equation? Delta Tf is equal to Kf into M, or M you know, Kf into W2 by M2 into 1000 divided by W1. What are the quantities is required? Delta Tf. See here, you go to the problem, and 1 gram of non-electrolyte solute means what? W2 is equal to 1 gram. W2 is equal to is dissolved in a 50 gram of benzene. 50 gram of benzene is W1 is equal to a 50 gram. W1 is equal to a 50 gram. Lower the freezing point of the benzene by 0.40 gram. Just to look here. Here, there is given the delta Tf. In the last problem, we have calculated the delta Tb by subtracting a TB minus TB naught. The both the way they will give, directly they will give the delta TF or delta TB. Here they are given the delta, directly the delta TF. The lower the freezing point, that is what? A depression in freezing point. Depression in freezing point is what? Delta TF is equal to 0.40 Kelvin. Delta TF is equal to 0.04. The Kb, the mole of the freezing point depression constant. The Kf for benzene is 5.12 calorie kg per mole. Only you have to substitute the value and find out the M2. So you can do it in a, you should do, you should solve this problem. All of you. The minimum, you have to solve the one problem in each method. So you can go through the textbook, you can find many problems. Out of that, you have to all should solve these three problems. Okay. See, this is the third method of what the your colligative process. One is the RLVP. Second one is the elevation in boiling point. The third one is the depression in a freezing point. The fourth method is osmotic pressure. I think it's clear for you. So, what is the, you have to, point of examination, you have to remember the equation. What is the delta TF is equal to AF into M. M is what? A molality of the solution. You know what is M? W. All should know what is M. W2 by M2 into 1000 divided by W1. So, therefore, the final equation is what? Delta TF is equal to Kf into W2 by M2 into 1000 divided by W1. And substituting the value, you will get the answer. Only thing is what? You have to know the equation, formula, and you should be able to understand the whatever the given in a problem. In the problem, freezing point is given means you have to, which method is a depression in freezing point. The problem boiling point is given means what? The problem is from the elevation in boiling point. So the vapor pressure is given means the problem is from the RLVP, relative lowering of vapor pressure. So after this, we shall move to the another thing, the last colligative property, the fourth one is osmotic pressure. Osmotic pressure. So, what is osmotic pressure? What is osmosis? In day-to-day life, or in a nature, or in a home, we are observing some phenomena. For example, in your home, the raw mangoes are placed in a salt. ಈ ಮಾವಿನ ಮೆಡಿಯನ್ನ ಉಪ್ಪಿನಲ್ಲಿ ಹಾಕಿದಾಗ ಏನಾಗ್ತದೆ? It swings. It swings or stival. The one more thing you might have noticed: a wilted flower is placed in a fresh water. A wilted flower. ಬಾಡಿದ ಹೂವನ್ನ ನೀರಲ್ಲಿ ಹಾಕಿದ್ರೆ it revives. ಮತ್ತೆ ಪುನಃ ಅರಳುತ್ತದೆ. Or when a blood cell is placed in a salt water, immediately blood cell will collapse. The blood cell will collapse. Or the dry carrot is placed in a fresh water, it becomes refresh. In all these phenomena, the one common factor is all these have a membrane. This membrane is called a semi-permeable membrane. Semi-permeable membrane. What is the meaning of semi-permeable? Permeable means permits. Semi means in a solution. You have two components. One is a solute, and there is a solvent. The solute are little bit bigger than the solvent. What is this membrane? The membrane has so small porous, it only allows a smaller solvent particle, not the bigger solute particle. That means through this membrane, only the solvent particle can move. So, in biology, last year you studied the process called osmosis. Osmosis. See, osmosis, there you have studied. The osmosis is a flow of a solvent particle from higher concentration to lower concentration through the semipermeable. Remember it. What we have defined? The flow of a particle, solvent particle from higher concentration to a lower concentration. But they are defining the osmosis in terms of solvent. But we are defining osmosis in terms of solute. So we are defining what is osmosis. What osmosis is a flow of a solvent particle. We are also defining the same. We are a flow of a solvent particle from a lower concentration to higher concentration, lower concentration to higher. They are defining higher to lower. What is that difference? They are defining the flow of a solvent particle, or they are defining the osmosis in terms of a solvent. We are defining the osmosis in terms of solid. For example, suppose you have this is a NaCl or sugar solution. This is sugar solution. Solution. So it is connected to this is a water. Pure water. These are connected to a semi-permeable membrane. Semi-permeable membrane. So, if now this is a solution, this is a solution, this one is a solvent. Now the molecules of the solvent are moving towards the solution. This is a lower concentration compared to this one. We are defining the osmosis in terms of a solute concentration. In a biology, we are defining the osmosis in terms of a solvent concentration. So here the solvent molecule, this is a lower concentration compared to this one. The solvent has a lower concentration compared to the solution concentration. Therefore, this is a flow of a solvent particle from the solvent side to solution side through the semipermeable membrane. This is called osmosis. This is our study. See, all this phenomena, what is the process? Osmosis taking place. For the osmosis, what is required? A semi-permeable membrane. Semi-permeable membrane. What is that meaning of semi-permeable membrane? It permits only the smaller solvent particle, not the bigger solute particle. So, see, what is the semi-permeable membrane? Semi-permeable membrane may be a natural bladder or parchment paper, or it is a synthetic cellophane. So this is called osmosis. I will define osmosis one more time. What is osmosis? It's a flow of a solvent particle. A flow of a solvent particle from a lower concentration to the higher concentration, or from solvent side to the solution side through what? A semi-permeable membrane. This is called osmosis. Here, next is what is wherein osmotic pressure. Osmotic pressure. What is osmotic pressure? So, the osmotic pressure is the external pressure. Osmotic pressure is the external pressure applied on the solution side to just stop the osmosis. What is osmotic pressure? The osmotic pressure is the external pressure applied on the solution side to just stop the osmosis. Is called, what is that called? Osmotic pressure pipe. What is the osmosis? The flow of a solvent particle from lower concentration to higher concentration. Suppose you apply the pressure here, at one pressure, no osmosis taking place. No osmosis taking place. That pressure is called osmotic pressure. How do you define the osmotic pressure? It's the pressure applied on the solution side. to just stop the osmosis. That is the flow of a solvent particle from a region of lower concentration to higher concentration through the semi-permeable membrane. See, what is the reason of in biology? What you are defined? They are defined in terms of solvent. We are defining the osmosis in terms of solute. This is a lower concentration. This is a higher concentration. Which we are talking the solute concentration. Okay. Here, the experiment here also experiment shows the phi is proportional to what? The concentration and also the temperature. In other two way of case, the delta TB is proportional to the molality, delta TF is proportional to the molality. Here, phi osmotic pressure is directly proportional to the molar concentration and the temperature. You can use the R is the proportionality constant. I is equal to CRT. I is equal to CRT. What is C here? Here is a molar concentration. In other two cases, we are used the molality. Here we are using a molality. C is a molar concentration. So the phi is depends upon the two factor. One is the temperature, another is a molar concentration. So we can write the equation. Phi is equal to what? Phi is C is equal to what? Molar concentration is what? Number of moles of a solute divided by volume of the solution in liter. Now we have studied this. What is the molar concentration? Number of moles of a solute. V is what? Volume of the solution in liter. See, we have written like this: W2 by M2 into 1000 divided by V. See, what is this one? Number of moles of a solid. Suppose this is what volume of the solution in ml. In volume of the solution in liter, we are writing that it's N2 divided by V. RT. So, phi V we can take this side. What is N2? Number of moles of solid. How do you write? W2 by M2. Number of moles of solid is equal to mass of the solute divided by molar mass of the solute into RT. Here, what is this one M2? M2 is the molar mass of the solute. This is the fourth colligative property method. You can determine the molar mass of the solute. For that, what are the quantities you have to know? You have to know the phi, osmotic pressure, V, volume of the solution is liter. So, W2, mass of the solute, R is a gas constant, E is a temperature in Kelvin. See here, what are the units? Units is a little bit important here. So, this is a liter, this is liter, then the phi R should also, V is a volume in liter. And the phi is in bar, then the volume of R should be what? Volume of the unit of the R should be what? Liter bar. Liter bar Kelvin per mole. If the phi is in atmosphere, then what is the unit? Liter atmosphere per Kelvin per mole. So if V is in meter cube, phi is in Pascal, what is the unit of R? R should be the joules Kelvin per mole. See, we have studied the value of R. R is equal to 8.314 joule Kelvin per mole, or R is equal to 0.083 liter bar per Kelvin per mole, or R is equal to 0.082 liter atmosphere per Kelvin per mole. See, these are the units of value of R in the different units. So already you know this one. Suppose this is what? Liter bar 0.082. 0.082 liter bar. All you should know all these three units of the R. Usually they will give the Only mean liter only. Only mean liter only. Pi is in either in a bar or in atmosphere. The value is therefore R is usually 0.083 or 0.082. Here it's a liter bar, it's a liter atmosphere. So, and see the T is in calorie, no problem. WT is mass of the solute in gram. You can find out the molar mass of the solute. Only this is the fourth method to determine the molar mass of the solute. What are the other three methods? RLVP method, depression in freezing point method, elevation in boiling point method. This is a osmotic method. Actually, this method is better than other three methods. Which method is better? Osmotic pressure method of determination of a molar mass of a solute is better than the other three methods. Why it is so? Because one is here we are using a molarity. The laboratory, the calculation of molarity is easier than molarity. There they are using molarity. One more thing is we are measuring the pi osmotic pressure experiment we have to conduct. We are measuring the pi at room temperature. Any temperature you can measure. So we are measuring the room temperature, especially for biomolecules. Especially for biomolecule, they are stable at room temperature. Some they may decompose at on heating or cooling. In a elevation mixed boiling point method, you have to heat it, and depression in freezing point method, you have to cool it. But here we are measuring the pipe at a room temperature. See, this is the second advantage of osmotic pressure method. The third one is the magnitude of the pipe, the value of pipe is very high compared to the delta TB or delta TF or RLVC. So, therefore, suppose for the very, even for the very small amount of the solute also, we can measure the colligative property. In a, the elevation in boiling point method we have seen. In the elevation in boiling point method, what we have seen? The delta TB is equal to Kb into M. If molality is 1, delta TB is equal to Kb. Kb is already we know 5.2 Kelvin kg per mole. That means if one molar solution, the increase in boiling point is only the 0.52 degrees centigrade. So if the concentration is little lower, then the magnitude of the result is very small. You cannot measure it accurately. But in a pipe, the magnitude of the result is high. Then we can even for the lower concentration also we can measure the pipe easily. So this is the osmotic pressure method. So this osmotic pressure. What is osmosis? Already we know osmosis is what? The flow of a solvent particle from lower concentration to higher concentration through semi-permeable membrane. What is semi-permeable membrane? The membrane which permeates only the solvent particle, not the solute particle. Then we have defined the pi. What is pi? Osmotic pressure. How do you define the osmotic pressure? The pressure applied on the solution side. The pressure applied on the solution side to just stop the osmotic. Or you can define external pressure. The external pressure applied on the solution side to just stop the osmosis. That is a flow of a solvent particle from region of lower concentration to higher concentration. So this is again what the experiment shows. This is a colligative property. It depends upon the concentration. Concentration means number of solid particles. So phi is proportional to the temperature as well as concentration. Phi is equal to CRT. C here C is what? A molar concentration. How do you calculate the molar? Number of moles divided by volume of the solution in liter. So you should remember. Suppose 200 ml of solution is what? 0.2 liter. Okay, so this V is what? Volume of the solution is liter. Finally, you will get a pi V is equal to pi V is equal to W2 by M2 into R into T. What is W2? A mass of the solute. What is M2? A molar mass of the solute. R is a gas constant. T is a temperature. So by knowing all this, you can find out the M2. Here important is what? You should remember the V is volume of the solution in liter. So, and pi, usually pi is given in what? Atmosphere or bar or atmosphere. Therefore, what is the unit of bar? What is the unit of bar? Liter, bar or liter atmosphere. See, already I written what is liter bar? 0.083 liter bar or 0.082 liter atmosphere. Anyway, they will give this value of the R. Only thing is you have to only thing you have to remember, write the equation and substitute the value, so you get a final mark. See, this method is the better than the other three methods. Why this method is better? Because here the concentration we are using the molar concentration, and second thing is, so we can measure the pi in the room temperature, especially for the biomolecule. This is a very good method for determining the molar mass of the solvent. So the third one is the magnetic for even the dilute solution, or even for the dilute solution, we can measure the pi because its value is high compared to the other three. Therefore, this is a better method compared to the other three methods. Okay. Here also you can solve the, what you can find out? You can find out the molarity. But what you should remember, V is volume of the solution in liter. Usually they will not give an SI in it. They will give the what? The V in a liter, I in a bar or atmosphere. Then the value of, what is the unit of R? Liter bar or liter atmosphere, not joules per Kelvin per minute. No, it's a liter bar or liter atmosphere per Kelvin per kg. So, say one problem is there in the textbook. You go to the problem and solve it. See, it's a very easy. They have given the volume, they have given the pressure, osmotic pressure in a bar, and R value is also they are given. So R value is given, temperature is given. Only thing is you have to find out the M2. So M2 is equal to what? M2 is equal to M2 is equal to pi, sorry, W2RT divided by IV. So you can find out the molar mass of the solvent. After that, in this unit only, this osmotic pressure only, we are going to study some more things. I think this is clear for you. The post method. What are the post method? I will repeat one more method. One is the first method. P naught one divided by P1 P naught one is equal to x2 is equal to W2 by M2 into M1 divided by W1. This is called RMVP. It's equal to mole fraction of the solid. Here you can determine the M2. This is the first method of determination of molar mass. Here, what are the quantities here required? The vapor pressure of the pure solvent and vapor pressure of the solution. This is a colligative property. And the mass of the solute, mass of the solvent, and molar mass of the solvent. We can measure the molar mass of the solvent. And second method is delta TB is equal to KB into M, or KB, M is what? W2 by M2 into 1000 divided by W1. Here what? W1 and W2 are a mass of the solute and solvent. Delta Tb is what? Elevation in boiling point. It is a delta Tb is equal to what? Delta Tb is equal to Pb minus Pb naught. Naught stands for a pure solvent. The boiling point of the solution minus boiling point of the solvent. If you know the delta Tb, we can find out the M2, and by knowing the W2, W1 and Kb. Kb is a constant for the solvent. Then similarly, we have discussed the delta Tf is equal to Kf into M is equal to Kf into what? W2 by M2 into 1000 divided by W1. Here also you can measure the molar mass of the solute by knowing the depression in freezing point, the freezing point depression constant, and W1 and W2. Finally, we have discussed the phi V is equal to what? W2 by M2 into RT. Phi V is equal to W2. This is an osmotic pressure method. Here phi is what? This phi is what? Osmotic pressure. What is the unit they are usually give? Either in a bar or in an atmosphere. Then V should be what? V should be in a liter. V should be liter, and W2 is the mass of the solute in gram, and M2 is the molar mass of the solute. R, what is the value of R? If it is in a bar, if it is in a bar, if it is in a liter, what is the value of R? 0.083 bar liter per Kelvin per mole. By knowing the phi V W2 R and T, you can find out the M2. I think already I told it's a better method than the other three methods. Okay, finally, we are going to study the one more thing here in osmotic pressure. In osmotic pressure, we are going to study one more thing, the isotonic solution. Isotonic solution. See, already you know, ISO, when we use the ISO is same. Tonic means a pressure, osmotic pressure. The two solutions having the same osmotic pressure are called isotonic solution at given temperature. Because the osmotic pressure is directly proportional to concentration and the temperature. Osmotic pressure is directly proportional to the concentration and temperature. If you know the osmotic pressure, sorry, the or given at given temperature, osmotic pressure is depends upon the concentration. See, what is isotonic solution? The two solutions having a same osmotic pressure at given temperature are called isotonic solution. That means they should have the same concentration. Anyway, so for example, what is the example here? The blood fluid. A blood fluid is isotonic with a normal saline solution. Normal saline solution. In an injection, you might have picked the injection. The injection is injected with a normal saline solution. Why it is so? In internal nervous system, there should not be any osmosis should be occurred. Because the these two are isotonic. There is no the osmotic pressure same osmotic pressure. Isotonic means what? Two isotonic solution are connected through a semi-permeable membrane. Two isotonic solution are connected through a semi-permeable membrane. This is one solution one and this solution two. They have the same osmotic pressure. They are connected to a semi-permeable membrane. There is no osmosis taking place. See why you have to inject it with a normal saline solution? Because it is isotonic with a blood fluid. So if the concentration of the blood fluid and the normal saline solution are same, therefore there is no osmosis taking place. Such a solution are called isotonic solution. What are isotonic solutions? The two solutions have the same osmotic pressure at given temperature. Such a solution, no osmosis taking place. The solutions are called isotonic solution. There is no osmosis taking place. For example, the blood fluid is isotonic with a normal saline solution. If the blood fluid is placed in a concentration of the solution more than the normal saline solution. The blood fluid is placed in a concentration of solution, saline solution more than the normal. Then what you are expecting here? This is a semi-permeable membrane. The outer membrane is what? Semi-permeable. If the outside concentration is more, then the solvent from the inside has to be come out the outside. The blood cell will shrinks. The blood cell will shrinks. This is called exosmosis. The common you can observe in a home. Suppose you place the your grapes Your grapes in a salt water. After some time, the fresh grapes in a salt water. After some time, the grapes will shrink, shrivel. So this is called exosmosis. Exosmosis. Similarly, if the blood cells are placed in a saline solution, its concentration is more than the normal saline solution. The exosmosis is taking place, and this is called the blood cell will shrink. This is called the higher concentration solution is called hypertonic solution. Hypertonic solution. What is hypertonic solution? The concentration is more than the normal. It's called hypertonic solution. See one more. One more is hypotonic. 1 minute, we'll complete it. The hypotonic. One more is hypotonic. This is what hypertonic. This is what isotonic. This is hypotonic. Suppose the blood cell is placed in a saline solution, which is a lower concentration than the normal saline. The blood cells are placed in a saline solution, its concentration is less than the normal saline solution. Now, the water molecule enter from outside to the inside. This is called end osmosis. The blood cell will swells. This is called the what? The solution is called the hypotonic solution. The process is called exosmosis. See the isotonic, the two solutions have same osmotic pressure. Hypertonic solution has a higher osmotic pressure than the compared to the another one. Hypotonic solution has a lower osmotic pressure compared to the another blood cell. So all these you have studied. What is the blood? When the blood cell will shrink, when the blood cell will swell, and there is no osmosis taking place. So, what are the things we have discussed here? What are isotonic solution? What is hypertonic solution? What is hypotonic solution? What is isotonic solution? The two solutions have same osmotic pressure at given temperature. Okay. The other things we shall discuss in the next class. Anyway, I thank you for listening to my class. Okay. Suppose you are facing any problem, please comment either on a WhatsApp or in a live chat. See, will come up with that problem. We'll solve that problem, and that is help for you as well as us also. So please tell your opinion. Say how you are, whether the class is useful or not. Tell all these things straight away. No need to hesitate. We will take it as a positive. But anyway, thank you one more time.